In this video, we're going to reverse engineer a BMW S54 engine mount from scan data. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to use scan data again, but this time we're going to be recreating a mechanical part. Now the reason we're doing this is because oftentimes when people install low mount turbo kits on the inline six in the BMW E36, E46s, oftentimes the engine mount gets in the way because it's a rather large assembly. So I have scan data that's been comprised of a couple different scans. It's missing a few pieces. It's got a lot of triangles. So we're going to work with this in Fusion 360 to understand the process, figure out what we can do, and maybe some of the workflows that we should follow. And then ultimately, we're going to recreate a scan data engine mount. And obviously, we're not going to recreate it as OEM, but we're going to create it with some modifications. So the first thing that we want to do is, because scan data is oftentimes not aligned to a coordinate system, or at least when it's brought into Fusion, it doesn't instantly align to anything that we have. What we want to do first is we want to create an empty component. I'm going to call this one S54 scan. Once we have that empty component, I'm going to activate it, which means anything I do from here on out, if I create a mesh, it's going to be put directly in that component. And I'm going to expand that so we can see it. Then I'm going to go to my mesh tools and select Insert Mesh. Now, it's important to note that I'm not going to be supplying the scan file for this, so it's just kind of a follow along to see how we would do this. So we're going to go to insert that. It's a 3MF, OBJ, STL, any of those mesh files will work. Depending on the number of triangles you have, it's going to take a little bit of time for it to come into Fusion 360. In general, CAD programs are not great at dealing with large amounts of mesh data. They're just not built for it. So once it does come in, we want to make sure that the unit types are correct. Now I know in this case that the unit types are going to be millimeters on the scan. We can talk about ways in which we can deal with that. Then the other thing we want to do is we want to think about where this is in location to our origin. So if we show the origin for the component we created, you can see that it's over here. So we can flip the direction. It's not really going to be that important for what we're doing, but we might want to either center it on our coordinate system or move to ground. Now center it will put this directly at essentially the center of mass. It's the center of the bounding box because it doesn't really have any mass. It's just an open scan. But that's essentially what's happening here. Then I'm going to hide the origin and I'm simply going to say, okay, I'm going to let it import the scan right there. And we're going to worry about the coordinate system downstream because oftentimes even moving it to the center is not really going to help us. So the next step in this process is to create some planes that are referencing the geometry that we need. In order to do that with the way that the mesh workspace is set up in Fusion 360, we need to go into direct edit mode. This is going to give us direct access to the mesh, so we're going to select the body and we're going to say OK. This also gives us a chance to clean up any straggling pieces of the mesh that we might not need. So for example, this data right here, I'm going to change my selection tool to Window Select. I'm going to drag a box around it, and then I can just hit delete on the keyboard to get rid of it. Going through the process and cleaning up the mesh is very time consuming, so I'm not going to spend a lot of time cleaning up this mesh. I'm just going to deal with the performance lag that happens from having all these extra little pieces. Because the main points are going to be to create some planes that help us reference geometry that's important to us, and also for us to figure out a way that we can align it to our coordinate system and we can utilize the mesh data. So the first step in this process is going to be to create a plane from 3 points. Anytime you have scan data and you zoom way in, you'll notice that we have a lot of variations in the surface. So we have to be careful where we pick. Now, this generally happens for a couple different reasons. One can be surface imperfections. These pieces are cast aluminum stock. So there could just be an imperfect surface there. It could have oil or grime built up over time. Maybe it just wasn't cleaned or prepped. Another reason might just be shadows, the direction the scanner is looking. And oftentimes we can kind of tell the scans that were put together as one based on the shadows or the areas that are missing. So in this case, what I want to do is I'm going to start by selecting a point kind of on the outside of that face. I want to look here. I want to select a clean point out here. And then I just need to pick one of the other mounting bosses. So again, find a clean point. And now what we've done is we've created a plane. We're going to say OK to that plane. We're going to right click and repeat that again. Now, if we need to, we can create another plane off of other reference geometry there, but really the only other important bit for us is going to be the mounting point here. Now, the way that BMW does this is there's actually this sort of tapered slot feature on this side to help with alignment with the stock bushing, but that's not really important to us. However, the location of it is very important to us. So we're going to, again, create a plane off of 3 points. And what I'm trying to do is look for this face that is continuous, and I'm going to grab my 3 points off of that. And lastly, I'm going to do this one more time. We're going to right click, repeat it. I'm going to rotate this around, move it over. And now I need to grab the mounting point on the inside. Now, the main reason I need to do this is because I want to know the center point of that circle. So the location of this face isn't as critical. It's just based off the thickness of the cast aluminum, but it is going to be important to us to get that shape right there. Now that we have that data, I'm going to say OK, and I'm going to finish my direct editing. From here, there are a couple other things that we can do. When we go to create, we have this create mesh section sketch. When I select this option and I select a sketch plane and a body, what I'm able to do is actually sketch based off of the intersections. So I'm going to select my mesh body. I'm going to grab my section plane, which is this plane we created here. And then I'm going to say, OK. Now, once I do that and I create a mesh section sketch, it's going to allow me to create sketch elements and place those based off of those references. So at this point, nothing has really happened. And if we go into our sketches, you can see a sketch was created and there's a bunch of noise, a bunch of data that happens. If we edit this sketch and we take a look at it normal to our sketch, let's go ahead and just pull it up here. Now what we have from the create menu is we have something called fit curves to mesh sketch. When we use this, there are a couple different object types that we can have. We can fit straight lines, arcs, or splines, closed splines, circles, or ellipses, and then we also have these path direction options. For a bolt hole, what we want to do is we want to create a circle, and we want to select our references. So you can see here that this is really jagged, but what it's actually doing is it's creating this circle based on the average center position of everything we selected. We can then go in and we can add a diameter to it. Now this is a little bit over 12 millimeters. I'm going to say 12. And now we have a 12 millimeter hole exactly where the center of that is. Keep in mind that this is not fully defined. It can still be moved around. So it's a good idea to dimension this either relative to your coordinate system or some other geometry. For our example, I'm going to lock the center so it doesn't move and finish that sketch. So that's the basic process that we need to follow when we're trying to create mesh-based parametric models. Now, keeping in mind that the scan data is messy and usually is going to be messy, let's repeat this process by creating another mesh section sketch, and it's going to be based on our mesh body once more. Once again, we want to think about the mesh data that we have at our disposal. So now that we have another mesh section sketch, what we can do from here is once again go in and we can create those holes. But a problem that happens when we do this from time to time is that we may or may not have enough data to actually capture these as holes. Another quick tip I want to make sure that we do is I want to set my camera to orthographic. Typically, I keep it perspective with ortho faces, but when you're working with planes that are not normal to our coordinate system, it can get a little tricky. But let's hop in here and let's create or edit our sketch that was created, and let's try to use that fit curve to mesh again. And let's see if we can get a circle to be placed here. And you'll notice that we don't have enough data. You can see that what we're end up getting here is nothing that aligns to our sketch. So the way in which we can actually make this happen is in the input to create that mesh section sketch, we can use some numerical inputs to offset it, or we can use a plane that's a little bit lower in the mesh where we have cleaner data. This is where it's going to be extremely important that we actually come up with clean mesh data. If we expand the sketch, you can see that we've got this mesh section. We don't have an edit option here. So what I'm going to do for now is I'm just going to simply hide it, and I'm going to recreate it. Again, we're going to select the same mesh body, section plane, and then I'm going to expand my numerical inputs. The numerical inputs are going to allow us to modify things like the x distance, the y or z angle. If I select minus zero point 0.5 millimeters, it's going to push it down just slightly into the mesh. And you'll notice that we're getting a much cleaner solution here. We have a little bit more of that edge, and that's going to allow us to actually capture that data that we need. So sometimes making sure that we can push it down into the mesh a little bit or find a cleaner position on the mesh. And again, this relates back to creating that plane based on the low points of the scan data. If we created them all on the high points, we would have even less mesh data to work with. So now let's edit this sketch. Double click the mouse wheel to center, and I'm going to zoom in. I'm going to go to my Create Fit Curves to Mesh section. And again, we're using the circle option. And now when I select this, you can see it's a little bit closer to where it should be. This is going to allow me to create a circular reference based on that mesh data. Keep in mind, again, and I can't stress this enough, the number of triangles in the mesh data that you have will slow this process down considerably. So you need to make sure when you're doing this that you clean up, or at least spend the time to clean up your scan data, and it will really help you downstream. So once again, I'm going to just go ahead and select that point. It's going to take a while because it has to analyze everything that we selected. It's going to figure out where the center of that circle can be. It's going to look for potential curve deviations. And once it's happy with all of those, it'll place that circle for us. I'm going to do this 2 more times. We're going to select that edge, allow it to place it in this upper corner. Note that when you're doing this and you're trying to replicate things like the pads on this foot here, you're going to want to use some of the other options like the fit curves with straight lines. And then you're going to want to come back and use things like a spline or a fillet in the corners. It's going to depend on your geometry, which is always the case. But in this case, you know that these are going to be straight lines and these are going to be large true arcs. So you wouldn't want to come in with a true spline for the entire thing. And if you have something that has a little bit more curvature to it, then maybe a spline would be applicable. But in most cases, you're probably going to want to use lines and arcs. Now that we have their locations set, we need to think about the actual dimensions between them. So D on the keyboard, I'm going to go between these two. I'm going to right click and make sure that it's aligned. And notice that it's roughly 70 millimeters. And I know for a fact that the distance between these two holes is actually 70 millimeters. So you can see that based off the scan data, we were remarkably close using those fit mesh curves and those options where it's automatically placing a circle based on the average. So I'm just going to say 70 millimeters, and that's going to get me exactly where I need to be for the distance between these. Again, because we're in a mesh sketch or we have these mesh references, it just takes a little bit longer. Now, if you have an extremely high or fast processor speed and your computer can handle this mesh data, that will certainly help, but it's going to be a product of the way that the CAD program, in this case Fusion, is handling it. So you can see in this direction, 179.116 is where it placed it. I know that this is 180 millimeters between these two. Now, you might be thinking, if you know what the dimension is, why didn't you just recreate it? Why didn't you just put that value in? Well, in reality, that would be a fine way to do it if you knew exactly where it was in relation to the sketch or the meshes, in this case, the mesh sketch. But sometimes you don't have that luxury. Sometimes there's a lot of complexity in 3D and you really need to use the mesh. In this case, it worked out better just to see where it was. The last thing that I want to do is actually create a rectangle. I'm going to go between these two. And this is just a reference that I want to use. So that way I have a straight line between each of the holes. And because our coordinate system is a little bit twisted, this doesn't allow me to use things like horizontal and vertical. But if I can pick one bolt hole location that I can fix, so in this case, I'm going to pick this upper left-hand corner. And that's because this left-hand corner was the one that we used for the dimensions. I know that the square or the rectangle automatically has perpendicular constraints applied to it. And then I can go around and I can actually put a coincident relationship for each of these points at the corner of the rectangle. Now, 2 of them are already there because I used it to draw this edge, and then the third one is there. So really this upper corner is the only one that's probably off a little bit. And I can use the coincident constraint to put those 2 together. And now I know that I'm matching the distance between each of these mounting locations based on the factory mount and the bolt pattern that we're working with. Again, because we're inside of a mesh reference sketch, it takes a bit of time, but there you can see that we have it now. This also is going to give me a nice reference for building the plate. And in this case, what we can do is we can select this rectangle because we know it matches all of the bolt holes, and we can just simply offset it. So I'm going to take this and I'm going to offset it outwards until it encompasses the pads. And that's going to be about 15 millimeters, and I'm going to say okay. Another thing that we should consider if we are trying to design something like this is anytime we're adding these reference edges or reference rectangle, we do want to make sure that we make them construction if we don't want them included in our extrudes. It's not strictly required because we can select profiles, but it makes the selection process much quicker just to simply take at least one of those edges and convert it to construction. In this case, I'm going to select all of them, and I'm going to expand my constructions just so I have those planes visible, and then I will finish the sketch. I'm not going to go through the entire process to model everything. I am going to skip a few steps. You know, that rectangle wasn't fully defined. It's always a good idea to fully define your sketches. And in this case, because everything was a little twisted, I kind of locked one corner and I made sure that everything stayed in relation to each other, but I didn't spend the time to make sure that it was fully defined. But now we have the mounting point location and we have the upper point location. I'm just going to rotate this around and we can begin building geometry. Now in this sketch, I didn't actually create the entire outside pad or the face that this is going to mount to. That still needs to be done. But another thing that I do want to make sure that we convey is how to align what we've done here to the coordinate system of the rest of the model. So I'm going to go back and I'm going to activate the top level of my design. I want to show the origin. And when we look at this, you can see that my origin is here. And a couple ways that we can do this is we can use tools like align. And align will not work on a mesh body. So you can use things like move copy on a mesh body, but you can't use align. And you have to keep in mind if you're using move copy to move a body, like a mesh body, all the references, the sketches, the planes, everything that we did beforehand, those options are not going to be there. So it's important that we do use the configuration that I'm working with here where we create a component and then everything that we did was inside of that component. The sketches, the planes, everything, including the mesh body. Because now it allows us to do things like take this plane, the plane that we created, and we're going to align components. We're going to take this plane and we're going to align it with our, in this case, XY. Now, if we look at this from the left-hand side, what this does is it flattens this plane, the plane that we have on our mesh, and it brings it so that it is in line with our, in this case, XY plane. Now, if we want to capture the position, we'll check that and say okay. And now what we've done is we've taken the entire component and we've moved the entire component, its sketches, its planes, everything, we've moved it to another location. For this example, also, I'm going to go ahead and hide the mesh body. I don't know that it'll speed up the processing time at all, but I'm just going to hide it so we're only seeing the sketches, and it should rotate a little bit quicker because it doesn't have to calculate all those little triangles. Now, if we want to rotate this so that our sketch is in line with an axis, again, we can use the align tool. We're going to do components again. We're going to select this edge, and I'm going to select my y-axis as a reference. Notice it pulled the whole thing over. We're going to capture its position and say okay. We could also use this option to go from point to point. So we could have taken the corner point and aligned it to the origin and then rotated it afterwards. Any of those options are fine, but just note that we are going to have to do this in a couple steps. There are other options with move copy and moving components where we can go point to point and move to the coordinate system. It's a little cumbersome. It doesn't always work great. So I like to do it in a couple steps just to make sure things are working. Now, if I want one of these bolt hole positions, for example, this one to be at my origin, I'm going to select it, and then I'm going to select the origin. And one thing we need to do is we need to pay real close attention to any icons that display on the screen. because you'll notice that this automatically flipped the orientation. So if we flip it around, if we bring back our engine mount, motor mount, you just want to make sure that the orientation is correct for whatever you want to do. We're going to capture its position and say OK. All right, at this point, we've gone 20 minutes and we really haven't done a whole lot. And that's part of the problem with working with mesh data. It really is helpful to have limited references. If you only need the mounting points, then hack away everything else. If you know what you need, you can just go ahead and get rid of everything else. Now what I want to do is I want to come back and activate my scan. That's just the component that I was using. And inside of here, I want to begin to build out this motor mount. So I'm just going to extrude this plate. We know that the bottom's at the right location. I'm going to make it 10 millimeters thick. Then I also want to create a mount at the engine. So to create the mount at the engine, we know that the mesh sketch is not at the right location. It just has the right geometry. So I'm actually going to start a new sketch on this plane. And then I'm going to use create project include or P on the keyboard to bring that circular reference from our mesh sketch over into our new plane. And again, the references are really going to depend on what you need specifically, depending on what kind of motor mount you are going to be using. If it's got just a single bolt in the center or if it's got multiple bolts, then you're going to have to design for that. But again, I'm going to project include, I'm going to bring that circular reference, and then I can hide the original mesh sketch. I don't need to see it anymore unless I need some of those other references to know where to place some geometry. But for this example, I don't need it, and it really is just slowing the performance down because we have so many converted or intersected elements from the mesh that it really just doesn't make sense to keep it visible. For this example, I'm going to just use C on the keyboard, and I'm going to make a 50 millimeter pad. Keeping in mind that even though our view on the screen is not aligned, you can see that we do have an X and a Y axis that is aligned. So if we needed to make a rectangular or a trapezoid or some other shape, then we could use the horizontal or vertical constraints to help us out with that. All right, let's go ahead and finish that sketch and turn this into a solid. All right, so let's zoom out so we can see everything we have. Remember that this plane here is the plane that we created to represent where that geometry is. And the sketch that we created, even though we projected it, it ended up going on to that inside edge. But that's okay, we can still work with this. All we need to do is select the geometry to extrude, and then we need to say we want to offset it to a specific object. And that object is just going to be a plane, and then the distance that we're going to extrude this is going to be 10 millimeters. We're going to say okay. And then we can hide any other sketches that we've created. All right, so now that we have this data, there's a couple things that we need to keep in mind. The mesh is really slowing us down. Now, having the mesh data inside of this design is causing us all kinds of performance issues. It takes long for anything to happen, but now we have the mounting plate where we need it at the block, and we have the mounting pad where we need it at the chassis. So we can see that everything lines up and we're not really worried about where anything is anymore. So we can right click on the mesh and we can select remove. Remove will allow us to place a feature in the timeline so that we can bring the mesh back at any point in time if we want by simply suppressing or deleting that feature or rolling it to a different place in the timeline. But getting rid of all of these triangles is going to reduce the calculation that it takes every time we have to rotate the model. Because the way that Fusion works is all of those triangles are calculated every time we rotate it because the lighting and shadowing effects and anything that we're doing just are really being calculated constantly. So now we have our model, it's aligned to our standard coordinate system. We have our mounting pad here and we have our mounting pad here. We can hide some of the other planes because we don't necessarily need to see them. We can hide the default origin, we don't need to see it. And now we need to connect this to this. And that's where it's really going to come into play for figuring out where our geometry is going to go. The way that I'm going to do this is I'm going to create an offset plane. I'm going to do it off of this face, but I want to select the center point of this hole. Now you'll notice that I'm not getting a center point location, I'm getting an edge point, And the reason that's happening is because this isn't a true arc or a true circle because it was based off of the mesh data. So you can see that I don't have that center point. If you need the center point, then the way that we can do that is by going to construct, and we can create a point that goes through a cylindrical reference. So we can select the center of a circle, sphere, or torus, and we can pick a reference that we want, or we can create an axis. So either of those would be perfectly fine, just depends on what you need. For my example, I'm going to do a point at a circle, sphere, or torus. And when I try to select this, you'll notice that it's not allowing me to select this geometry. When I go to cancel, let's go to construct, and let's try to do an axis through a cylinder. And you can see that this one actually allows me to do it. So that's going to be fine. We'll go ahead and we'll use that as our reference. Okay, so let's try this again. Let's go to offset plane. I want to pick the end of this face, and I want to select the cylindrical boss as a reference. And notice that when we go to the side, that puts it directly in line with here. So typically what you want is a vertex to select, but in this case, it will work if we just select that. When we go to to object, however, it doesn't let us select that to measure. We really need a vertex to select. And you can see because those references weren't working that we're having trouble. There's another way that we can do this without the axis if we have a sketch that includes a center point. So we can bring the sketch back and we can click on that point. And now the important bit here is that this is a parametric reference. That means that if we change the sketch, if we move the bolt hole location or we make any adjustments to it, then we can easily go back and have everything downstream update. When you use the distance option and just click on something, all it's doing is measuring. It's using the inspect measure tool, it's figuring out how far away it is, and it's not actually capturing that parametric relationship. Now that we have this plane, I'm going to right click and create a sketch on it. Remember, all this time we're working directly in this S54 scan component. And once we have a sketch on this plane, we're going to want to create an intersection between all of the solid bodies. This is going to help us better understand exactly where all of our references are. So let's go to create, project include, and intersect. We're going to change the selection option to bodies. We're going to select that body, and we're going to select this body, and we'll say OK. Notice that this is upside down based on how we were looking at the design before. It really just depends on how you're looking at your own designs. In this case, it's actually mounted almost sideways from the way we're looking at it. But you know, if you have problems, just use the view cube and rotate it around to whichever way you're comfortable looking at it. So for me, I'm going to go ahead and just rotate this around so that that's on the top. So this is from the back view and it's upside down, but that's okay. Remember that we're directly in the center of this and we need a bolt to go through, or we need access to put a nut on. So depending on the size of that and how you want to design your bracket, we can do things like go to the midpoint, that triangle reference there, and begin to come out, and then we can build our bracket from there. To transition from a straight line to an arc in Fusion 360, all you have to do is go back to the last point on the sketch line, hold down the left mouse button, and then it'll convert it to an arc. You can see here, even now, we're having these calculation time issues. It's just taking a lot of time to calculate this file. So I'm just going to make a tangent arc there. I'm going to zoom out a little bit. And I'm going to just bring this out tangent. I'm going to just pick a point out in space. I don't really have a dimension value that I'm aiming for. And then I'm going to create another arc. I'm going to come down past our bracket. And then I'm going to come over to it and hit escape. I'm going to make sure that that line is horizontal. Remember, it's based on the X and Y that we see in our sketch. If these are askew for whatever design you're working on, then make sure that you are careful about using horizontal vertical, but they will align to the red and the green axes in whatever design you're working on. We want to make sure to get off of our constraint, and we want to take a look at what we've modeled so far. So we need to create a plate that we can use to mount, everything together. And what we're going to do is we're going to create a plate that comes outside of this mount. So we're going to come out and over. And we're also going to do the same thing down here and connect it back together as one solid. So we need to be sort of mindful of what we're designing and what we have to work with. Having a cylinder up here makes it a little bit more difficult, but now we've got sort of the basis for what we're doing. I'm going to start another line. I'm going to come up here and I'm going to begin coming over at an angle, and then I'm going to make another arc. These arcs necessarily, or they don't necessarily have to be concentric, but in most cases, for visual reasons, you want to be careful where the center points of the arcs are. We can kind of see the center point of the large arc that we already created is somewhere around 80 or 85 millimeters up from the origin. So I'm going to come to here, and then I'm going to begin converting this one to an arc and decide how we want to interact with that plate. Part of it is going to depend on the amount of space you have. Obviously, if you're trying to fit a turbo or something in this area, then you have to be mindful of the size of object that you're avoiding. And that's obviously, it's going to be based on whatever specific design you're working on. But this is just a general look at how we would go about taking the scan data and we would process it and work with it in Fusion 360. And I'm going to be honest, the slowness of working with this with the mesh data as opposed to just sketching a design is incredibly frustrating. It's taking quite a bit of time. The other way that we can speed this up, and I'm going to show you this. I'm going to hit escape. I'm going to finish the sketch, and I'm going to save this. I actually haven't saved the design yet. So I'm going to call this S54 motor mount. The way that I'm going to speed this up is I'm going to take this component and I'm going to convert it to a derive. You can see that there's all kinds of errors with the mesh. It really didn't like removing the mesh from this design, but I'm hoping that I can get around that by going to create derive, and I want to derive this entire component. Notice that it's trying to bring the mesh with it, and we're going to say okay to that. You can see that it's just selecting it. The bodies are here, the sketches are here, and that's really what's important. I'm going to say okay. And what I'm hoping will happen by using derive is now you can see that we've got this external link. What we've done is we've only brought over these two bodies, and I'm hoping that this will make this a little bit easier and more manageable to work with. Whenever you're working on an assembly, a derive is a one-way sort of data transfer. So any changes we make to the original will come down to this design. Any changes here will not go back. You can see that we didn't bring in any of the history here, but we do have the sketches. Notice that when we right-click, we don't have an option to edit the sketch. We can slice it, we can create a new sketch, and we can copy it, and that's probably the best way forward, or we can break the link to the original design. Really just depends on what you're doing. Breaking the link is not going to bring in any additional data. The mesh is not going to come with it, but the sketches are now open and we can see them. But again, we don't have full access to working with it like we do back in the original. But again, that's okay. What we're going to do is we're going to take that construction plane that we created and we're going to start a new sketch on it. Again, for whatever reason, it's flipped upside down. If we're happy with what we had here, we can use P on the keyboard and we can project it and bring it in. This line here was not complete yet because we didn't fully define that arc. So, we could work with that. I'm going to say cancel and I'm going to start from scratch and just see if it's a little bit faster. But again, we do have those options. So now that we're starting with a clean slate, let's go ahead and intersect with those bodies. Again, I'm going to go to this back view. Now let's start at the outside this time. I'm just going to arc this around. And you can see that it's already working quite a bit faster. So I'm going to come and I'm going to mount to the end of this plate. I'm going to make these two tangent. And then I need to decide how I'm going to interact with the rest of the plate. So I'm going to come up and over just like we did before. Convert that to an arc. And I probably want to move that around a bit more, but I'm just going to bring it to here and then straight line it there. Make sure that these are tangent. Then I'm going to move these points around until I'm happy with the shape. So you can see that line right now is not perpendicular, so I'm going to make sure that I've got that reference there. And remember, we need to have enough room to get to the hardware. That's something that we need to be mindful of. So I'm going to come up, over, and down. I'm going to make sure that this is perpendicular with that or parallel with something else. It really doesn't matter. And then I want to add a dimension here. If we know how much room we need, I'll give myself about 1 inch. And then I want to round those corners off too. I don't really want these corners to be sharp. Give them a 10 millimeter. It's enough to get a wrench in there. Now, theoretically, you're not going to be taking the motor mount on and off a ton. So hopefully this is a one-time job. And I've worked on a lot of cars that are much more complicated or difficult than just having to get, tough access to one of these bolts or nuts. So that looks pretty good so far. Obviously, we want to go in and fully define it. You want to add dimensions to everything. I don't really want to spend the time doing that, but I'm going to go ahead and just quickly add dimensions based on what it looks like now. And I'm going to add a slight lip here because there are a couple more topics that I do want to cover, and I want to make sure that we understand. So now I'm going to take this and extrude it. I'm going to extrude it as a single plate in both directions. So we're going to change the direction type to symmetric. And I'm going to make this one 10 millimeters on each side. And I'm going to say that this is a new body. I don't want to combine it with anything else, but this is a new body. And now what we could do is we could weld these together. Now, in reality, this is a pretty big component. It's a lot wider than this plate. It really needs to be thinner. We could do 2 plates. We could gusset it. There's all sorts of different things that we could do. This video was not intended to be an ideal engine mount design video, but this is kind of the way that these things are done for these inline sixes when people are trying to put low mount turbos on them. But now is the point where we need to figure out what we do with this. How do we get it out of Fusion 360 to manufacture it? Now, typically what you would do if you were laser cutting or water jetting something like this is you would save it as a DXF. Now, the main way to save as a DXF in Fusion 360 is for us to have a sheet metal component. Now, we could convert this to sheet metal. We have the option where we can turn it into sheet metal, but there's actually an easier way. Because we defined everything in a sketch, so we're in the sketch 1, and that's our profile. What we can actually do, assuming that we have a complete closed profile, is we can right-click and we can save the sketch as a DXF. Now, the nuance here is to make sure that everything that you have in that sketch is everything that you want to send out. Now, it's not true for this case because I have all the projection stuff. So one of the quick ways that we can do this is by selecting the face and just creating a new sketch on that face. That will automatically project the profile, and then we can take this sketch and save it as a DXF. So I'm going to go ahead and save this as S54 DXF, and then I'm going to open it back up. Now, I do want to save this one as S54 mount derive, so that way I have it. All right, so one more nuance thing, and I know I keep saying one more, but you cannot take this back into the original. Even though we broke the link, and technically they're not still linked, if you try to insert this back into the original, it's going to give you a warning or an error. So that's something that you do need to avoid. But that is the main way or the main process that we would go through if we were trying to create something from scan data. Now, again, I mentioned it was extremely frustrating during the process. Depends on the scan. Now, if we have a scan that we can very easily remesh or reduce the mesh count or cut away all the stuff we don't need, it'll go much faster. And that's done very early on in the direct modeling process in the mesh. But if you have to bring the entire mesh and it has a lot of extra pieces that are sort of floating out in space, it really drags down the system. And it's not just Fusion, it's any parametric CAD program. They're just not meant to handle mesh data like that. So at this point, we have now created a motor mount based off of the scan data. We've learned a couple of things, and if there's any main takeaways, I would say make sure that you're comfortable working with the mesh data. If you have to make adjustments, you use direct edit. You can create those planes. Make sure that everything's stuck inside of a component. That way you can reorient it to the coordinate system of the entire design, make it much easier on you. And from there, if you have any questions, if you're trying to do this on your own, please let me know. I know it's a cumbersome process, but thought it was important to cover it at least in some manner. But now we can kind of understand how to make this work, and hopefully you guys can think of some cool ways to apply it. Again, any questions, please let me know. Either send me an email or add it to the video. As always, thanks for watching, and I'll see you in the next one.